Welcome back, friends. Now we're going to talk about the constant c, which tells us about horizontal shift. And we have two conditions that we want to consider while we're looking at this. So the first thing is that sometimes we have a situation where that b value is equal to 1, so it's not there. And in that case, it's much easier for us to think about the horizontal shift. But when b is a value other than 1, we have what is called a phase shift, and we'll talk about that as the third example in this video. So what we're looking at here is we have a b value that is added. When a number is added, we know it's a shift because it is inside the grouping mechanism with x. We know it is horizontal. But because it's with x, we know it's going to do the opposite. And there's kind of a hint there because our standard form has this minus in it. All right? So C represents a horizontal translation. Translation's a fancy word for shift. C affects the phase shift in a ratio with B. So first we're going to look at when B is equal to 1. Because that's not a phase shift, that's just literally picking the graph up and shifting it left or right. So as long as the b value is equal to 1. So the c value we're going to remove is going to be the opposite because there's that minus again in the standard form. So if I have a c that is negative, and mind you, what I'm thinking about, like x minus negative c. What would that look like? That would look like x plus c. So we would think that looks like it goes right, but if we have a negative c value, we're actually going to shift left c units. And if the c value is greater than 0, we're going to shift right c units. So greater than 0, that's like saying x minus some positive c value. So it looks the opposite in the problem of what it actually is. I think that'll be easier for us to see after we look at these examples. So here we have two functions. We're going to sketch the graphs of the function. I have y equals the sine of x minus pi. So it's added and it's on the inside, so that lets me know it's a horizontal shift. And looking at this, I would think, okay, well, I'm going to go to the left because it's negative. But this is actually going to shift right pi units, which means we are going to take our x value and we're going to add pi to each of the x's. So when we think about those key points, our 5 key points here, they are all going to shift forward pi units. We're going to add pi to each of these x's. I think I left one of those points off, but they're all moving forward pi units. So my graph is now going to look like that, and that looks really messy. So 0, 0, if I add pi to the 0, that gives me pi 0. Here I have pi over 2, 1. If I add pi to pi over 2, that's going to take me to 3 pi over 2. So I have 3 pi over 2, 1. My next key point is at pi 0. So if I take pi 0 and I add pi to that, that gives me 2 pi 0. My next key point down here was 3 pi over 2, negative 1. Adding pi to that takes me to 5 pi over 2, negative 1. And my last point, 2 pi, adding pi to that, that gives me 3 pi 0. So I still have that cosine curve. It's just shifted to the right pi units. So let's look at this one more time with example B. Here again, we have a cosine graph. We have x plus pi over 2. This is a value that is added or subtracted, but added on the inside. Adding lets me know it's a shift. Inside lets me know it's horizontal. I would say, well, that looks like it's going to go pi over 2 to the right, but it's actually going to shift pi over 2 to the left. And if we think about trying to write this in our standard form with a minus, that would be x minus negative pi over 2. So putting that minus in there lets me see we are going to shift left pi over 2 units. That means each of my xy ordered pairs, I'm going to subtract pi over 2 from each of those x's. So if I list my 5 key points on my cosine graph, I've got 0, 1, pi over 2, 0, pi negative 1. I'm going to erase that. I'll write it here in a second. 3 pi over 2, 0, and 2 pi, positive 1. So I said each of these points, I'm going to say x and subtract pi over 2 from it. The y isn't going to change at all. So my new points for the graph on B here, I've got negative pi over 2, 1, because that is 0 take away pi over 2. Pi over 2 take away pi over 2 gives me 0, 0. Pi take away pi over 2 is pi over 2, negative 1. 3 pi over 2 take away pi over 2 is pi 0. And then I have 2 pi take away pi over 2 is 3 pi over 2, 1. So these new points, everything is shifted left pi over 2 units. And my graph is the exact same curve, it's just a little bit to the left. So let's look at in conjunction with a b value that is not 1. So in both of these examples, the coefficient in front of my x was 1. So this rule applied if that b, the coefficient in front of x, was 1. So again, considering our standard form, if we've got both a b and a c value, and this b is not 1, b not being 1, the phase shift c over b is going to tell us which way we go. So remember, the c value that we pull out is always going to be the opposite of what we look like, and then we're going to divide by whatever b is. So if c over b is negative, we will shift left c over b units. And if c over b is positive, we'll shift right c over b units. So here we have a graph. You'll notice that the coefficient in front of x is not 1, and we have a c value. So looking at this, b, we would say b equals 2, and c is positive pi over 2, because that is bx minus a positive c value. So what is this going to do? This is going to cause the graph to shift c over b units. This is going to be a positive number, so we're going to shift to the right. So c over b, my ratio c over b, which is my phase shift, is pi over 2 over 2. And essentially, this means we are going to shift right, that's not a pi over 4 units. How would this change my traditional XY ordered pair? So we know the period is going to shrink by half. So instead of shifting pi over 2 units, we're going to shift pi over 4 units. So we're going to take those x values, we're going to divide them by b, and then we are going to add my c over b. Or rather, we could say x plus c divided by by, because it shrinks the period and then we shift it, this phase shift quantity. All right, so let me make that look a little nicer. Let's start with our key points for sine. We have 0, 0, pi over 2, positive 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So as I said, I'm going to take these, I'm going to take my x value, I'm going to divide it by 2, and then I'm going to add pi over 4. So 0 divided by 2 plus pi over 4, I've got pi over 4, 0. Pi over 2 divided by 2 is pi over 4, plus pi over 4 is pi over 2. So we've got pi over 2, 1. Pi divided by 2 is pi over 2, plus pi over 4. Now I have 3 pi over 4, 0. 3 pi over 2 divided by 2, that's 3 pi over 4 plus 1 pi over 4 takes me to pi, negative 1. And then 2 pi over 2 divided by 2 is pi, plus 1 pi over 4 gives me 5 pi over 4, 0. So this graph is going to be shifted, but also shrunk horizontally at the same time. So my new points, we've got pi over 4, 0, pi over 2, 1, 3 pi over 4, 0, pi, negative 1, and 5 pi over 4, 0. So it is shrunk horizontally, and it is shifted right pi over 4 units. So it shrinks horizontally by a factor of 1/2, and it shifts right pi over 4 units. We have a new period of just pi. Remember, the period is the absolute value of 2 pi divided by my b value. So 2 pi divided by 2 is pi, and you see that new period showing up in here. So that's the trickiest part of it, and especially when you're working on your lab, I want you to pay close attention to this example and really think about what we did here. So we've got one more example in this video series, and even in this chapter, where we're going to talk about applying all of these transformations simultaneously, right? So not just having 1A or 1B or 1C or 1D, but all of them at the same time. And how can we create that new graph?